First things first, who are you, what's your role, and where do you work?
My name is Sai Vennam, and I'm a principal solutions architect at AWS. What I do is work with customers that are migrating, modernizing workloads, moving to Kubernetes. I work with practitioners, and I also like making digital content that helps people learn Kubernetes. I've been doing it since 2017, 2018 on YouTube, back then with the IBM Technology channel, now on Containers from the Couch. It's what gets me excited. I love creating content and seeing people learn new technologies. It's what gets me going.
And what are 3 emerging Kubernetes tools that you're keeping an eye on?
Yeah, so one of the tools I'm really excited about is Kueue. Essentially, it allows operators to schedule jobs to take advantage of GPU resources. This is great, especially because GPUs are hard to come by, they are expensive, and these workloads don't necessarily need to be low latency. Essentially allows you to queue jobs instead of what Kubernetes normally does, which is first come, first serve for pods, which isn't always great for this use case. And another tool and capability, this is not emerging necessarily. Karpenter, of course, been around for a while now. Customers are and have been using this in production. But one thing I'm really interested in is new features in Karpenter. The one that I really am keeping an eye on is node overlays. So Karpenter decides instances to to spin up in response to pods that haven't been scheduled or are unschedulable. And so with node overlays, you can change the metric that Karpenter uses to define those nodes. So, maybe your organization has certain discount plans on certain instances. Maybe you want to favor certain types of instances over others. And that's exactly what node overlays lets you do. I think that's another cool tool. The last one to keep an eye on is Kueue. Essentially, it's a composition infrastructure as YAML type approach to automating your infrastructure. Kueue essentially makes it so you can abstract away complex Kubernetes resources, whether they're, maybe simple resources like deployments or custom resource definitions. And you don't need any custom controllers to do that abstraction. And it has dependency graphs kind of built in, does everything in a Kubernetes native approach. So Kueue, keep an eye on that. I think we're going to see a lot more folks using that to orchestrate not just Kubernetes workloads, but combining it with custom controllers to do cloud deployments, cloud services deployments as well.
In Kubernetes, which parts of cluster operations truly need to stay in the hands of platform teams, and which could realistically be abstracted or automated without losing control?
Yeah. So at AWS, we have this concept of undifferentiated heavy lifting. Of course, this is a concept that exists everywhere, but we like that phrase because essentially it refers to work that's uninteresting. It's just kind of, another word I've seen used is plumbing. Everyone needs to do it. Everyone needs to maintain certain things. And so, especially in the world of Kubernetes, there are certain things like cluster upgrades and keeping things up to date with the latest versions of Kubernetes and, essentially, all of these operational tasks that exist. These essentially can be moved over to cloud provider control. And that's exactly what Amazon EKS Auto Mode does. It's a capability that allows you to focus on what really matters and allow the cloud to manage components like kube proxy, VPC CNI, certain controllers like the Karpenter controller for storage, the EBS CSI driver. This is a lot of acronym soup. Just know that, these are things that essentially every cluster needs. So why spend your time maintaining these? Allow the cloud provider to take care of it for you. That's kind of what we're hoping to accomplish with Amazon EKS Auto Mode.
How do AI ML workloads expose the limits of today's scheduling and capacity planning models, especially when GPU, ephemeral jobs, or burst demand are involved?
You know what's funny? My answer was actually for that question. So what was that first question again?
In Kubernetes, which parts of cluster operations truly need to stay in the hands of platform teams, and which could realistically be abstracted or automated without losing control?
Yeah, absolutely. So this kind of goes back to that challenge with GPUs, and essentially, you don't have an endless supply of them. And especially with AI ML workloads that don't necessarily always need to be low latency, especially training jobs. This is one of the things where Karpenter comes into the picture. There's certain GPU specific capabilities like MIG from time slicing of GPUs. We talked a bit about Kueue to allow you to queue up jobs. So, a single GPU can be utilized at a higher percentage. So that particular metric, utilization, is something that's critical here as well. So all of those tools come together to help businesses more efficiently use their GPUs, bring their utilization rate up.
When clusters scale up easily but rarely scale down or rebalance efficiently, what patterns or mechanisms could improve cost and utilization without manual intervention?
The answer here is resoundingly Karpenter. Karpenter allows you not only to spin up the most cost-efficient instances in response to workloads that need to be scheduled, but when those workloads schedule down, it'll efficiently bin pack them as well. A simple example I always give is maybe at peak traffic, you're using 3 nodes at 80% utilization, but as traffic starts to dip, maybe those nodes are now at 20% utilization across 3 nodes. With bin packing, maybe you can run all of those workloads on one node, get it up to 60% utilization instead. Maybe you can use a smaller instance. Maybe you can use things like Graviton or ARM-based processors or Spot instances to further save costs on cost. These are all the kind of things that Karpenter helps with. Critical in the space right now, especially with GPUs.
Looking towards the future, I know we've spoken a bit about AI. We just celebrated 10 years of Kubernetes. What can we expect in the next 10 years? AI, other technologies? What do you think, Sai?
Yeah, this is going to be so interesting. When Kubernetes was emerging, it was really fun for me to make content, teach folks about Kubernetes. But now we're seeing a lot more maturity build, and practitioners are implementing more complex patterns. And we see it even here at KubeCon with the conversations and the level of conversations moving up to a 400, dare I say even 500 level, even the talks that we see here, getting more advanced. And as we see practitioners really start to implement these Kubernetes best practices and move to scale, that's what I'm excited for in the next 10 years, working with people and helping them reach that level of scale.
What's next for you, Sai?
Yeah. Let's keep building on that. What's next for me? I've been building content and helping folks learn the basics of Kubernetes. I think it's time to level up and go even deeper. One of the workshops that I maintain, eksworkshop.com, is kind of where we're centering a lot of these new patterns, these new capabilities that you can do with Kubernetes. Check it out, eksworkshop.com. This is part of what's in store for me as I move forward here, helping practitioners build more advanced capabilities on top of Kubernetes, leveraging what they need to really grow in scale and maturity.
How can people get in touch with you?
Get in touch with me on LinkedIn. I'm very responsive there. Reach out, Sai Vennam, reach out on LinkedIn. And if you want to see the content and if you want to see, workshops, videos, that kind of thing, you can always catch Containers from the Couch on YouTube as well.